Today we are going to talk about hyperbolic functions. Before I start with the hyperbolic, I would just remind you by the transgeometric functions, or they call it circular function sometimes. Okay, so we know these functions. Without right triangle, you cannot talk about any of these unless you have right triangle. Okay, if you have the opposite A and the adjacent B and your hypotenuse C, so you can write sine theta as opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse, and etc. Right? So this is a function, I remind you. But remember, before we go back to our title, hyperbolic function, without a right triangle, you cannot talk about these transgeometric functions. Okay? And we have some rules for this one. This is exactly like the circle equation. Do you remember the circle equation? X squared plus y squared equal to a squared. A is the radius of the circle. This is why sometimes we call it circular. Okay. And we know these rules, we can get them from the basic. Okay. And also we have the cosine for the two angles, addition or subtraction. We can do it. If you have subtraction here, you will have plus here. Okay, so it's the opposite side. So one of them will be minus, the other one will be plus. If you have plus here, you will have minus. Okay. Now let's go for, do we have something called sine x? So what you add here? You add h. H coming from what? The word hyperbolic, right? The word hyperbolic, and it is originally Arabic. In Arabic, they call it jas. Ja, it is a sign. Zin from zaidi. This is why they translated into hyperbolic function. But originally it was Arabic. Mathematician who has done this one. He found what? He found no need for the right triangle like this one, and he found the algebraic term for the exponential function over 2. Okay, look at this one. We will go for this one and graph it. So y equal to e x minus e minus x over 2. He found this function like this one. So he found it symmetric with respect to the origin. So it is odd function. Okay, yes, it is odd function. What is the odd function is? I know the odd function. It's the function f, when you replace x by minus x, you will have the same function with opposite side. Okay, so if you replace here x by minus x, what do you have? Yes, you have e to the minus x minus e to the minus x over 2. So this one, take minus as a common factor outside. You still have this one here, and you have, yes, e to the x coming from this one, minus e to the minus x. Okay, so sine x, or this term, is odd function, right? Okay, and it seems when you graph it, the odd function must be symmetric with respect to the origin. If you have this one concave up, you have the opposite side in the left hand side. Okay, That's fine. So he found this function sin x is odd function similar to what? Similar to sine. Sin x is odd function because sin x is equal to minus sine minus x. Okay. And he said, what if I take someone like cosine x? This is e to the x minus, instead of minus, plus e to the minus x over 2. So if you replace x by minus x, you will have it e to the minus x plus e to the minus x over 2. So you end up with e to the minus x plus e to the x over 2. When you have add is a commutative operation, so you can have e to the x plus e to the minus x over 2, which is the same function, the original function cosine x. So it is even function, even function. So cosine is even function similar to the even function. When you replace x by minus x, you will have the same function. Okay. Okay, so sin x is e to the x minus e to the minus x over 2. This algebraic term, he call it sin because it is behaving like sine. It is odd function, right? And the algebraic term, instead of the minus here, he put plus. It's becoming even function similar to the cosine, right? Okay, let's graph the other one. I'll copy this one. This one into plus. Yes, the blue one. Yes, do you remember this one? This is like when you have a bridge. Have you seen in the United States and Turkey also you have a bridge, hanging bridge? So this is a graph of the hanging bridge, right? It is a cosine shape, right? Okay, now we got the idea and we start with the hyperbolic function similar to the trigonometric functions. The hyperbolic functions, no need for a right triangle, but it is behaving like sin x. It is algebraic term e to the x minus e to the minus x over 2. It is odd function. Also, cosine x is the algebraic term e to the x plus e to the minus x over 2. It is even function. I remind you again, the even function, the blue one, symmetric with respect to the y-axis, but the odd function sin is symmetric with respect to the origin. Good. So let's go and see. I just remind you, we have sine square theta plus cosine square theta equal to 1. Do we have something like this? Let's go and square sine squared. Sin square x. It is what? It is e to the x minus e to the minus x over 2 square. Let's square this one. When you square the denominator, 2 will be becoming 4. E to the x square minus 2, the first, times the second, plus the second square. This is how to square a complete square. The complete square, x plus y, I just remind you, x plus y square is equal to x square plus 2xy plus y square. Okay. Now, what do you have? E to the x square, when you square it, it will be 2x. It is the same as e to the x times e to the x. This is e to the x square, right? When you multiply and you have the same base, you just add the power. The power x plus x will be 2x, right? This is how to get the square. Now, e to the x times e to the minus x, you have the same base e, and you add this one, x minus x, so you have e to the 0. E to the 0 is what? Can you tell me e to the 0 is equal to what?
1.
1, excellent. So you have 2 here, plus this is the same as e to the x squared, but in negative, over 4. This is sine square. Let's go for the cosine square. Cosine square x. Do you think, what do you have in this case? Yes, it is e to the x plus e to the minus x. I'm just taking this up, one up. Okay. If I do the same with cosine square x, what do you have? You have, yes, e to the x plus e to the minus x, this is a cosine, over 2 square. The difference in the minus here is becoming positive here. So you will have the same answer without the negative. Yes. So you are expecting this one to be what? Yes, e to the 2x plus 2 plus e to the minus 2x over 4. If you add this one together, if you subtract this one together, you will have what? Yes, when you subtract cosine square minus sine square, so everything will be deleted and you end up with what? Cosine square x minus sine square x. I know in both sides you have 4 and everything will be deleted, and you have 2 from the first one and plus 2 the first one, so you end up with 1. Yes, very good. So you can do this one similar to the sine and cosine in the circular function, and you can say, yes, I have, yes, cosine square x minus sine square x equal to 1. Yes, this is why they call it hyperbolic, because it is hyperbolic equation. Okay, but if you remember, yes, sine, I'll write it down. Cosine square plus sine square yes, I know. Cosine, the other one, cosine square cosine square x plus sine square x equal to 1. This is what? This is circular, yeah? Circular equation. So remember, this is why they call it hyperbolic function, because this equation is hyperbolic equation. And this one they call it circular equation because this is exactly like the equation of the circle. Okay? Do you remember the circle? X squared plus y squared equal to a square. A is the radius. Now, we know there is a connection between sine, cosine, which is a hyperbolic function, and the trigonometric function sine and cosine, right? So if I go back to this one, and I would like to add here h to this one. I add h to this one. So no need for the right triangle, right? Okay. But this one will be what? Yes, e to the x minus e to the minus x over 2. If I would like to add h over here, no need for the right triangle. And this one will be what? E to the x plus e to the minus x over 2. Yes, you can go straight forward and add h, no problem, right? And this one is not here. Okay, you can add h. Yes, you can add h. You have everything similar to this one. Okay, but there is no algebraic value for this one. This is algebraic term, right? And also you can add h here. Yes, you can add h. Oh yes, no algebraic. Okay. Now you can add h here. Sesh, yes, you can h here. And this is. So it's not a magic. It is proved, right? And he found the same thing working with this one for the main trigonometric identities becoming hyperbolic identity. Okay, so let's go for our main object. What is the differentiation? The derivative of the hyperbolic function. It is not new. Why it is not new? Because I know the derivative d by dx for what? The first one, sin x, and I know this is what? This is d by dx, and I know sin x is what? Yes, e to the x minus e to the minus x over 2. Fine. This half is a constant, so you can take it outside. I'm revising the derivative again, okay? And I would like to differentiate e to the x minus e to the minus x. Now the derivative is linear function, so this half, open bracket, d by dx for the first function minus d by dx for the second one. Now, you know what is the derivative of the exponential function? Yes, I know. E to the x, and the derivative of the power is 1, no need for it, minus e to the minus x times the derivative of the power, which is minus 1. Now, minus minus is plus, so you have e to the x plus e to the x over 2. What is this one? Yes, I hear you saying what? This is cosine x, right? So it is similar to the derivative of trigonometric functions. The derivative of sine is cosine, right? So this is the first example. Let's do the cosine. D by dx for cosine x. Yes, I know. This is d by dx, and my cosine is what? Yes, e to the x minus e to the minus x over 2. Again, if I am differentiating, I'll take this half outside, d by dx for the first one plus d by dx for the second one. Okay, this is half. The derivative of e to the x is e to the x. The derivative of the power is 1 plus the derivative of e to the minus is e to the minus x. The derivative of the minus x, which is the power, is minus 1. Now this minus with this minus will be half e to the x minus e to the minus x. So what is this one? Yes, this is half e to the x minus e to the minus x over 2. Yes, this is a sine, which is a sine x. Yes, this is the difference. Note the derivative d by dx for the cosine x is what? Minus sine x, right? So this is the difference between the trigonometric function or circular function and the hyperbolic. The hyperbolic, the derivative of cosine doesn't have minus, right? Okay. Now I will leave you having the derivative of the rest of the function. You have the basic. What is the basic? Yes, sine x is equal to e to the x plus e to the minus x over 2, and you have cosine x equal to e to the x minus e to the minus x over 2, and of course you have all of these function. You have all of this one. This is your basic, so you can just replace e to the and d. You get the derivative of sine and cosine, and then you can get the rest of the derivative. I will leave it for you. Now, if you have your calculator, you will see beside sine x, you have a red color here. With the red, you have -1, right? So to press this one, you have the alpha here, or sorry, shift. Is it shift or alpha? Shift, sorry. Shift. So the same color as the shift. But we know what does it mean, this one? Yes, as I see, sine inverse x is f minus 1 of x, for f of x is sine x. It is the inverse function. So if I know this is x, this is a, b, c, and right triangle, so sine x is a over c. But sine inverse of a over c is x. This is the angle has sine equal to a over c. This is what does it mean, the inverse function in the trigonometric functions, right? So can we do this one? We know the meaning here because we have a right triangle and we know the angle has a sine equal to a over c. So the sine inverse is the angle which has sine equal to a over c. What about this one? Can we talk about sine inverse x? How to find this one? I'm just asking you, right? Or fine, sorry. Find the inverse function of y equal to sine x and find its derivative. So I would like to have the inverse of this one and differentiate the inverse, right? Okay. Y equal to sine x. I don't have any information except the derivative, the definition of the sine. What is the definition of the sine? Yes, e to the x minus e to the minus x over 2, right? Now I would like to have the inverse function. So I will get multiply by 2, so I have 2y equal to e to the x minus e to the minus. Sorry, before I multiply by 2, I multiply by e to the x. When you multiply a fraction by anything, you have to multiply the numerator and multiply the denominator. Why I'm doing so? I'm doing so to get rid of one of these. I will have only e to the x, okay? So when you multiply each term in this one here. So you have e to the x times e to the x minus e to the minus x times e to the x over 2 times e to the x. Now, e to the x times e to the x, the base is the same, and you add this one, x plus x, minus the same base, minus x plus x. So you add the power only, and you have e to the x. So you end up with, yes, e to the 2x minus e to the 0 over 2 e to the x. E to the 0 is 1, and I still have y over here. Now I multiply by 2 e to the 2x. So what do you have? I have 2y e to the 2 e to the x equal to e to x minus 1. This is an equation, right? I'm looking for the inverse, so I'm looking for x, not for y, right? So I move everything in the other side, so I have, it's better to move it to the left hand side. So I have 0 equal to e to x minus 2y e to the x minus 1. This is algebraic equation. I can write it as e to the x square minus 2y e to the x minus 1, 0. If I got e to the x by m, for example, so I have m squared minus 2m minus 1 equal to 0. So I can find m, 1 and 2. I have two roots. Do you remember the minus p plus the quadratic function? Root square of p squared minus 4ac over 2a. Yes. So I get e to the x will equal to, remember, a is 1, b is minus 2y, c is minus 1 in this quadratic equation, right? A is 1, the coefficient of a square, the coefficient of degree 1 is minus 2, and the constant value is minus c. So I have a and b and c. So the root e to the x will equal to minus b, so minus 2y plus or minus root square of b squared minus 2y squared minus 4 ac 1 times minus 1 over 2a 2 times 1. Now e to the x will equal to, this minus minus will be 2y plus or minus root square of minus 2y squared is 4y squared, minus minus will be plus 4 over 2. I can take 4 as a common factor from here, so I get it outside. When you have 4 outside the root square, it will be 2. Now I can get 2 as a common factor. Now I can cancel out this one, this one. This is e to the x. I would like to have x, so I get the inverse function len. So len for e to the x, they will cancel each other, right? So I have here len for y plus or minus root square of y squared plus 1. Now, are you going to take the plus or the minus? Remember, when I explain to you the logarithm function, I'm telling you this is the shape of len x. Remember, x always positive. You don't have a negative value inside the len. And I know this y less than the root square of y squared plus 1. So root square of y squared plus 1 less than the root square of y squared, which is y. So if you subtract y minus root square of y squared plus 1, you have a negative value. So you will never accept the negative value here. So x equal to ln y plus root square of y squared plus 1. Once you reach this stage, you will have, yes, if y equal to sin x, so x will be sin inverse. Okay, ln y plus root square of y squared plus 1. Now I know how to find the algebraic expression for the inverse function for the first hyperbolic function. I know how to differentiate this one, right? I forget something. You have to replace this one by x, because I make it sin inverse x. Okay. Now I know how to differentiate this one, d by dx for sin inverse x will equal to d by dx for this expression I got, ln x plus root square of x squared. Yes, ln x plus root square of x squared plus 1. It is not a new stuff. This is, I know how to find d by dx for this one. What is the yes, this is the implicit derivative. The big box is what? It's the ln. The smaller box inside is, yes, x plus root square of x squared plus 1. So I know this is implicit derivative. So what is the derivative of the ln? 1 over whatever inside this one, x plus root square of x squared plus 1. And then, yes, I would differentiate what inside this one. Okay, now I have 1 over x plus root square of x squared plus 1. What is the derivative of x? Yes, d by dx for the first one plus d by dx for the second one. It is better to write this one as x squared plus 1 to the power half. Yes. Now 1 over x plus root square of x squared plus 1. Here you have 1 plus, what is the derivative? Yes, you get this one. This is also implicit derivative, the power half here. And inside you have x squared plus 1. So you get the power down. Okay. And then you have to subtract 1 from the power. So you have half minus 1 times what? Times what inside this one? The derivative d by dx for x squared plus 1. I will do it in one go. Okay. So I know how to differentiate x squared plus 1. It's 2x only. Now this 2 will be cancelled out this one, right? So I end up with 1 over x plus root square of x squared plus 1. Okay. And here you have 1 plus x. Remember, this will be to the minus half. So when you have to the minus half, you can get it down. Okay. You can get it down by positive half. So this one will be minus half. So you get it down to the positive half. So you have 1 over, yes, x squared plus 1 to the power half. This is exactly what? This is the root square, right? Okay, so this is the root square. Now you multiply this one inside, okay, and you get the derivative of the sin inverse, okay? So easy to ask you, and you can do it yourself. Find the inverse function of y equal to cosine x, then find d by dx for cosine inverse x. Okay, so you can do the same thing. You just y as e to the x plus e to the minus x over 2 multiplied by e to the x, and then you solve this one as it is x equal to, you take the ln, you will have by the end y equal to the algebraic equation, then you go for d by dx for the derivative. I will leave it for you, right? So what we have done, just to make a summary for today, yes, we have the hyperbolic function. Yes, I link the hyperbolic function to the trigonometric function sine, but you have to add h, and also cosine, and you can add h. But in this case, once you add h, okay, no need for right triangle. Okay, this is algebraic term, e to the x minus e to the minus x over 2. And this is e to the x plus e to the minus x over 2. Because they are similar to the sine and cosine, so I'm expecting to have tan x as what? Yes, sine over cosine x, right? And I am expecting to have, codash x, to have it as cosine x over sine x. Okay, and also I'm expecting to have sec, but hyperbolic sec, it will be 1 over cosine x, and also cosec, but hyperbolic cosec, it will be 1 over sine. This is the hyperbolic function. This is the basic hyperbolic function. Let's have a screenshot for you. So you can substitute using the basic sine and cosine, and you can find the tangent, cotangent, secant, everything, right? Now we can use this one to prove some basics. You can square to prove cosine square x minus sine. You can prove that cosine square x minus sine square x equal to 1. Okay, and also you can find the rest of the identities for the hyperbolic functions, right? And next, we can find the derivative of this function by differentiating the exponential function. So we can find d by dx for sine x will be, yes, cosine x, and d by dx for cosine x will equal to sine without negative sine x, and you can go for d by dx, and if I go for what? For tan x, I have sec square, so I will have sec square here. X. I can go for d by dx, d by dx for cotash x. I'm expecting this one to not to have minus in the formulas of the derivative. Okay, so if you go for d by dx for, you can prove all of this one. Sesh x, you will have sesh x dash x. You can prove also. Just I'm again prove that. This is your assessment. I have done this one for you, and I've done this one for you. You can do the rest, right? Okay. Also, next, yes, I can find. I will get this one just for saving the time. Is why they call it hyperbolic, and we call it circular here, because any points here, if you write it as a cosine and sine as a coordinates, and you get the difference of the square, you will have hyperbola. But here, if you have the addition of the square, you will have a circle. And this is the definition of the hyperbolic. This is a proof of cosine square minus sine square equal to 1. This is tangent definition. This is a cotangent definition. This is the sesh. This is the cosesh. And you may heard in Arabic they call it katina or catenary. This catenary is like hanging bridge. So it's a hanging bridge using a cosine or the hyperbolic cosine, right? Derivative, yes, you can go for the derivative of sine and cosine by using the algebraic term as a definition, and you know the derivative of the exponential, and you can get all of these one using the definition. The inverse hyperbolic function, as I said, if you have sine, the black one is odd function, similar to the sine, and its inverse, sine inverse here. Okay, and y equal to x is like a mirror, so sine is reflecting over y equal to x to get your inverse. Okay. Or if you how to get the inverse function, as I explained to you, this is how to get. Yes, this is the expression for the algebraic expression for the inverse hyperbolic function. All of these one, either you can get it similar to this one, so you can write it down. Once you have cosine inverse and sine inverse and tangent inverse, you can find the derivative because it is a derivative, implicit derivative. Okay, and you know the derivative of the ln, so you can find the inverse of all of these one. Okay. And here I left for you some exercise. You can do it and see you next lecture. And sorry to be late.